Perfect. Yeah, so let's make this interactive. I have a few slides, but it's just, yeah, I kind of have a storyline, but I thought about talking about resource flows, starting from above and then diving into more technical stuff, but it's up to the audience, you know, where we'll go. So I call these enable patterns of resource flows in the context of a peer-to-peer economy. And I have to put a disclaimer up here, which is a common practice of Sensoricans when you present stuff and talk about Sensorica and the open value network model. There is no mechanism of representation of the network, so I can't claim that you know, I speak for the network. These are just my ideas. Yeah, and I thank all the people that have contributed to develop Sensorica and the models since 2010, 2011. So that was a long span of development, and there have been hundreds of people that have gone through the network. So this is not just my work. So I'm one of the co-founders of Sensorica. You can find me at Tiberius B on Twitter. And I put here a QR code. You can take a screenshot. This is where you can find the presentation on the Sensorica website. And you can also find some other presentations that are kind of complementary to this one. So we'll have the same QR code at the end of the presentation if you didn't have time to scan it now. Talking about resource flows or flows of resources or patterns of resource flows, you know, I can sit here and talk about how these things happen in a capitalist economy or in a communist economy, but I guess that's all known. And we're here because we share something together. We're part of this peer-to-peer, loose peer-to-peer Web3 movement and communities. So I suppose, you know, that the topic is flows of resources or new patterns of flows within that context of the peer-to-peer economy. And when we talk about resource flows, actually the notion of property is very important, because one of the aspects of property is transferability of resources. How do they go from one agent to another? So talking about property, it's key to understand resource flows, and it's also key to understand the economic context in which these flow patterns occur. So, you know, everybody knows about private property, public property, commons. You know, people talk about this for a long time. But what's important to understand here is that there are new forms of property that are today operational at global scale, which could become the backbone of a new economy. And these new forms of property determine how resources can flow in ways that they could not before. So that's important. So one of these new property regime is called non-dominium, and was proposed by Chris Cook. He developed this in the context of real estate. And if you think about the Bitcoin network, it's more or less an implementation of that. Okay, so non-dominium property regime. A non-dominium asset is an asset that doesn't belong to anyone and cannot belong to anyone. It's impossible to control it or to own it by a single agent. It provides permissionless access. Okay, so public property access is public, right? The idea is to make the asset available to as much as possible to all the citizens. And there are rules to make sure that these resources don't get depleted or damaged. But the focus is on access. The government can decide to revoke access to some people, and obviously, you know, if you're not a citizen, you cannot access some of these assets. So node is built on permissionless access. Okay, so if you take the Bitcoin network, the network physically, the physical infrastructure is made out of miners, computers, in the private property regime, so people own these, but one miner cannot offer the service, right? So the service is an emergent property of the whole network. So the question is, who owns the whole network? And the answer is nobody. Another interesting characteristic of non-dominium is that it doesn't need a legal infrastructure for enforcing or regulating access. And the Bitcoin network has been built with that in mind, okay? Outside of the reach of governments and their legal system to be able to control the asset. So that's, yeah, so these are the very specific properties of the non-dominion form of property. And another form of property that we use, we call it pools, or pools of shareable resources. And that's interesting. That's sort of an aggregate of resources that are under different types of property regimes. Could be private property, could be commons, could be shared property like a condominium, or it could be non-dominium form of property. And we see how this applies in the context of Fab Labs and makerspaces, how this concept is applied. So I think that the most important thing, you have a link there. If you open the presentation from the QR code, you can click the links and go to the OVN wiki and just dig more on these concepts of property in this case. So non-dominium is this new form of property that could be deployed globally, like we've seen in the case of Bitcoin, the Bitcoin network. And that could also be applied to physical resources. Like, as I said, this concept was proposed by Chris Cook in the context of real estate. And that, because we have a new form of property that we could implement, that drives new patterns of resource flow. So that's something very important to understand. So we're in the context of the peer-to-peer economy, and what digital technology also does is that it allows the existence of new type of organizations, these organizations are essentially open networks. So if I go back to the same example, the Bitcoin is an organization, and it's not a traditional organization, but it's an open network. In our language, you call that an open value network. So these networks now can exist because of this digital information technology. And what we need to understand here, it's like the question is why do they exist now at large scale? It's because digital technology reduces the costs of transaction. So Ronald Coase, with his transactional cost theory, tells us that organizations exist in order to reduce transaction costs. So what happens here is that in order to produce something, to have like a manufacturing plant, all the resources that are allocated to production, it's better to put it into a cocoon, which is called the organization, and allow these resources to flow more freely according to the internal processes of fabrication, and be allocated through roles within this organization, departments, and so on and so forth. It's more costly to operate a manufacturing plant in the open network. Okay, so the transactional costs are higher. So that's the very reason why organizations exist, is to put into a sort of a cocoon everything that it becomes too expensive to transact in the open market. So what digital technology does is that it reduces even further the cost of transactions. So a lot of things that they used to be within that cocoon, now they're happening outside. So when we talk about outsourcing, that's in large due to this digital technology. Okay, so if we take Ford, the car company, at the beginning of the last century, they're essentially doing everything in-house under the same roof. They're making their own screws, they're making their own, they were making a lot of things that were going into this car in the same plant. And as information technology developed, then a lot of these things, a lot of the parts were outsourced to other companies. So now you can coordinate a lot of production in the supply chain, okay? Because you have this information technology that makes it easier and faster and more efficient. So the breaking down of large verticals into supply chains is largely due to this technology. Now, what happens with blockchain is that that trend goes even further. Okay, so the way resources flow into a production context are greatly affected, okay, by the internet and the internet 3.0 with the blockchain. So the real cost, essentially, he told us that you know, why firms exists, and essentially that leads to the idea that open networks actually can exist. And then we have Yochai Benkler, who wrote a few papers about commons-based peer production, and it's sort of a theoretical analysis of this new production mode, and it lays down some more economic foundations for the existence of networks. So essentially, it says that open networks enabled by this digital technology, they have lower information opportunity costs, which means that because they're networks, they push the sensing to the core, from the core to the edge of the network. And so there's a lot of information out there in the environment that gets sucked in by all these sensors, which are all these contributors to the network. And that information, again, gets to the core and gets processed. So open networks capture more opportunities at lower costs than closed organizations, just because the way information is processed within these open networks. Another interesting aspect of open networks is that they are they're more efficient allocating resources. So instead of having a managerial approach, like in a traditional organization, you have people electing doing stuff, and like we see in the open source world. And also, commons-based peer production and these open networks, they bypass financial systems and the markets when it comes to their production and distribution. So that reduces or overcomes some of the market failures that we see in capitalism with firms. So what that establishes is that open networks. We understand why they exist. We understand the trend that went from the breakdown of verticals into supply chains, like outsourcing, the massive trend of outsourcing, and now the disintegration of these organizations into just pure peer-to-peer networks, or the existence of things like Bitcoin. Right? We can understand theoretically why they exist, and in some cases why they're more effective than traditional firms. So now we established that essentially we have new property regimes, and then we have a new technology that allows new types of organizations that give rise to new sort of a new type of economy, which we call the peer-to-peer economy. Just some historical pictures. This is a picture from the Sensorica lab, probably around 2016. When the lab was at its peak in terms of size, and that's a nice historical picture. You can see Bob Hogan and Lynn Foster, who are behind value flows, and you'll see value flows a little later. That was 2013. Yeah.
Not seeing the picture, Tiberius. Maybe it stopped. The slide stopped changing.
Oh,
there you go.
Maybe it's loading, or. Can you see this picture?
We can see it now.
Oh, okay. So you can see the lab, right? With a lot of people in it, right? Okay.
Yes.
So do you see Bob now? Do you see Bob and Lynn in the middle of the picture?
I don't know. There's a lot. The first picture was a few people sitting down looking at the camera, and the second picture now we're looking at has people looking at one person talking.
Okay. Yes. Yes. Okay. So so I'm back to the other one. People looking at the camera. Tell me whenever it loads. It seems like there's a lag. Probably the big pictures. I just made a copy paste.
Yeah, we can see the one where they're looking at the camera now.
Yes. Yes. So that's a nice historical picture that ties into the things that we'll talk about. So Bob and Lynn, they found Sensorica probably in 2012, late 2011, because we were trying to sort of steward our activities in the lab with spreadsheets. Okay, so what Sensorica implements, maybe I have to mention that, which ties into flows of resources. So we have the Bitcoin network, and Yochai Benkler spoke about commons-based peer production, and so it turns out that this peer production can be digital or physical, right? So Wikipedia, it's content produced by people as a network, which is kind of a hybrid model because it's sort of centralized in some sense, but it has a sort of an open component, has a long tail contribution pattern. So nobody's hired to produce content. So that's digital production, okay? All the open source projects online, they follow the same pattern. And now we have Bitcoin, right? So Bitcoin it's also digital production. It's a production of a service, which is like token exchange among people. The question back then was, can we transpose this model into physical production? And so what is the organization going to look like? So we understood these new forms of property. How can we implement these new forms of property in and around the lab? And what kind of tools we need to build in order to steward our activities? Okay, so you can see Sensorica as an open and permissionless network that engages in physical production. Essentially, it's like a sort of a seed, a precursor of what Ford would look like, not as a corporation, but as a decentralized network. Like, can open networks build cars one day? Okay, so the answer is yes, but we still have a lot of work to do because yeah, it's much easier to do digital peer production, and it's more difficult to do material peer production because you have to tie into real assets, the legal system that deals with that. And there's actually a project that is pretty advanced, and that's the sort of the missing link for scaling material peer production, which is Material, led by Vinny Gupta, who's a friend of Billy. Billy's right here. They worked together in the Maker Lab in London, and they were part of the
London Hackspace.
London Hackspace, yeah, part of the original how do you say, Ethereum community, right? That took shape in London. So Materium is really the missing. It took Vinny, 10 years to bridge blockchain with physical assets, and he developed Materium in the context of real estate. But that's saying that now material assets, physical assets, physical resources could be tied into blockchain infrastructures. And that's what Sensorica was missing. But so we prototyped all these processes, all these methodologies of work and governance and organizational structure. Not being able to connect to any blockchain anyway. When we started in 2010, Ethereum didn't even exist, so there was no smart contract and stuff like that. So yeah, but that's a lot of work to understand what material peer production is, how you can organize around it, what kind of tools you need, and Materium is that missing link to just build that infrastructure that can scale it globally. And Bob and Lynn are kind of, historically speaking, they are very important figures in this development. So essentially, when I say material peer production, it's a sort of a web of, I call it a Faber web, the web of making stuff. Okay, so how do you turn the internet into not just an informational network, but a network that allows people to make. So people talk about the web of value when they talk about blockchain. Well, we want to go a step further, because yeah, you can have cryptocurrency, but if it's not tied to a sort of a new mode of production, you only have a cryptocurrency for people to speculate. So all these kind of fungible tokens, they are useless. They're useful and even necessary. They're required when it comes to material peer production. So I think that's the real application of these kind of new technologies, is to support or work hand in hand with material peer production. Otherwise, they're just another form of currency. So it's serving capitalism. So it's not really, and you're not even utilizing the full potential. Resource flows. We put up a concept of true commons, which is a sort of in terms of implementation of these ideas. How do you represent a resource digitally in order to make it flow, in order to allow it to flow in the context of peer production? Okay, so let me go through these fast and stop me or ask questions about any of these points. First of all, that asset has to be represented on the internet, on the digital space, as organization agnostic, and it has to be capture resistant. Okay, so we understand resources only associated with an agent, be it an individual or a corporation or the government in case of public resources. So in order to allow peer production to function properly, we need these resources to be construed to appear to people as being organization agnostic. It doesn't mean that organizations cannot access and use these resources. They can, but they're by default global and shareable, and so they have a global mobility and accessibility, and they're shareable. Okay, so think about the Bitcoin network as an asset, as a digital peer production asset, the network itself, right? So it is organization agnostic. It is its own organization. Okay, its existence. It's not tied into any government, any corporation, or any individual. Right? It's a non-dominion form of property, and it's out there, and everybody can actually connect to it, and it's capture resistant. Access to it, to these resources need to be permissionless, which doesn't exclude rules. Okay, but once you make the rules, you can actually access these resources. And well, uncapturable, I guess I wrote it twice. When it comes to digital resources, now, one of the things that I think it's important is to make them hard to clone. Okay, so for instance, you have a digital resource that represents a 3D model of an object that you can 3D print. Okay, so a bunch of people get together into a network, and they decide to design some hardware, and they publish that design online. So what usually happens is that people download that and change it and put it on another database, and somebody else forks it and loads it onto yet another database. So what you have now, you have just a proliferation of versions of that thing, and the problem is that you don't know which one really works, which one has been tested, and which one are just like just hacks or trials. And what does is it breaks down collaboration around a particular asset. Into many clusters. So that's inefficient. That's a cost to peer production. So one of the things that is important here is if you have a digital asset that represents a 3D model, it has to be hard to clone, meaning that people have to contribute to that asset, or people have to fork that particular asset, and that fork is that reference to the original. It's kept somewhere. and it's not lost. So the internet has been designed with copying in mind. So things are very easy to copy. Well, we have to do something different here, and that's why the blockchain is very interesting. Thinking about NFTs. So yeah, you can snap a screenshot of an NFT picture, but it's easy to detect that that's not the so-called original copy, right? So provenance is important, and people have to gather around the same resource to collaborate. And these assets that are now sort of digitized, they need to be able to implement various property regimes. So you can have an asset that is that exists as a private property, as a public property, but also as a non-dominium or commons, right? So they have to support these different protocols that implement different property regimes. They're shareable by default, and they're fully specified, machine readable, so that you can do searches, and then you could kind of aggregate different assets according to their features or uses. And they're composable, meaning that you can put it together into larger systems. And they're able to interact with processes, and that's very important, and also ties to later we're going to speak about the technology for that. So assets need to interact with processes, and processes need also to be construed on the internet as organization agnostic. Okay, so that allows the Faber web, meaning that what you have now, you have assets that are to begin with, available to be found just by doing a search on the web. So you can find them. And some of them may be presented to you as private property. That's fine. That's tied to an agent, and that drives how these things can flow through transactions, market, whatever. And some of them are just a non-dominium form of property, which gives you access if you respect certain rules. So that drives another pattern of a different pattern of flows. So you can find them. You can have the rules of access. Okay, and now these assets can flow between different contexts of production. Okay, so let's say you find something that is in the non-dominium property regime. Many networks can actually tie into it and make use of it. That's exactly what happens with the Bitcoin network, right? You can build an ecosystem of applications that just connect to it, permissionless. And you can see all these applications as being different organizations that plug into the same asset for various reasons. Same thing with Ethereum. So all this ecosystem on top of Ethereum, essentially that's what it is. It is a non-dominium form of resource, of property, that is just hanging out there, and provides permissional access to it. So anybody can connect to the blockchain and build whatever applications they want. So that asset becomes floating around, accessible to use to different production contexts. That's very different than capitalism. It's, for example, if you walk into, I don't know, the Tesla manufacturing plant and you see a big CNC machine, you can't just duck into it and say, I'm going to do my project with this CNC machine. Okay, that access is not available for you. So that resource cannot flow into other production contexts outside of that particular agent because of the form of property in which it exists, right? So then you can enter into agreement with a company to say, can I use your facility? Can I use your machines, your equipment? And that has huge transaction costs. Okay, so okay, we can lend it to you, but we have some insurance issues. Let me talk to my insurer. What if you get hurt? What if you break the machine? So there's there's a whole range of complications when you deal with that kind of private property regime. So now resources can flow around, right? And that's what makes this peer-to-peer economy very very efficient. Because if you go to these if you go to a private, I don't know, manufacturing plant, most of the equipment in there sits idle for most of the time. Okay, and so it's rare or when all the production assets are utilized to their full capacity in a production context. So we're talking about the sharing economy, all these platforms that allows you to kind of to share the car and I don't know, lend it to someone or do Uber with your car. That's part of the same concept. It's just a hybrid, centralized kind of version of what I'm talking about. But we're going in the same direction. Okay, so making physical assets available to a wider context, allow it to be used in various production contexts. So that's the.
Sorry, can we just double check we're on the same slide? I can see the Faber web page.
Yeah.
Okay. Thank you.
I didn't understand. So okay. So can I move on?
Sure. Thank you. Sorry. Thank you.
Okay. So actually, let me start here. So when we talk about flow of resources, we have to distinguish two things, which is, I don't know if you see this slide, is like the Earth with some people around and a bunch of bubbles. Can you see that?
Yes, thank you.
Okay, so what I want to represent with this picture is like the world and a bunch of people that just, we can call them consumers, and a bunch of bubbles around, which are what I call production contexts. And this production context could be open networks, could be co-ops, could be whatever type of organization you can think of. So the idea here is that they're interconnected somehow, right? So they're interconnected in a way in capitalism and communism, but they're interconnected in a different way in a peer-to-peer economy. So when we talk about flows of resources, we got to understand two things. So first, how resources flow into production, and how resources flow from production context to consumption. Okay, so obviously we have the market-based flows that happen on both sides. Okay, so things that flow into a production context, we call that the supply chain. So companies, they purchase materials and components from other companies, and there's a market for that. It's a sort of a B2B market, business to business. And then once the product is made in capitalism, that goes out to consumers also through market exchanges, right? So we know that. The cosmo-local context, okay, which is advocated by Michel Bounds and the Peer-to-Peer Foundation, what it says essentially is that you have the cosmo-local essentially is everything light is processed digitally on the internet, like I don't know, writing Wikipedia together or writing Linux, contributing to the Linux code base, or collaborating on an open source hardware design. Okay, that's, you use a computer and use these applications and you develop these CAD files, and then you can share them on platforms or you can email to people. So everything light happens online, and everything heavy happens locally, right? So once you have a prototype from that 3D model, then you can actually make it, and you can make it in your house, or you can make it at the local Fab Lab or makerspace, or you can make it in a company. a company can take an open source design and just fabricate it and sell it to the local market. So that's the cosmo-local approach, where you kind of have intermediaries into for fabrication and distribution. You can have intermediaries. You can have a company, local company, that sells locally a product made from an open source design, right? The do-it-yourself is a more granular kind of process. Okay, so you have a bunch of people that design the thing online, and then I download the CAD file and I put it in my 3D printer in my basement, and I do it for myself. So in that case, the producer and the consumer, they're the same people. In the cosmo-local model, they're not necessarily the same. I can go to a fab lab because I don't have a 3D printer or a makerspace and say, can you guys print me this model? And there's also some electronic components that I don't know how to do. Can somebody help me do it? And you can pay them for that service, right? So there are patterns of flows into production, and there are patterns of flows to consumption. And for now, we can distinguish these three modes, these three patterns. When it comes to production, how resources flow into production in the Sensorica case. Here you have a picture of activities for prototyping something called the Matryoshka, which is like a public furniture. So the first picture on the top left, we were at a local company that made some the graphical design for this thing first. The top picture in the middle, we were at another local company that provided capabilities to manufacture, to assemble stuff. Okay, so we had this big CNC machine. We brought our plywood and we cut the stuff, and then we assembled it. The lower pictures are in the Sensorica lab. What's interesting there is that you have a bunch of people that are providing resources and time to make this prototype within this network, okay, within this group, for various reasons. Okay, so so how do resources flow into this production context? So you have the printing company that says, you can use my machines to print stuff, and I have an interest in this project, because if you guys sell these things, I'm going to be the agent that will provide all the graphics that you're going to put on top of this thing. So I'm investing with my machines into this project. So you can just come there and use my space and try out some graphic designs. The CNC machine also, the company was also interested in this project. So they are supplying their assets. So now that CNC machine doesn't become the property of the network. We don't have to buy it. There's no market transaction for that. We're not even renting the CNC machine. So it flows into the production context just because there is an interest. The company says, I will give you an engineer and some CNC machines and some space to assemble the thing, because if you sell a bunch of them, I know that you're going to come to me, and I'm going to be the one cutting your wood. So everyone has an incentive why they want to pour time, skills, and production assets, resources into this project. At the bottom there, we see bottom right, the guy that is smiling. He's a software engineer, and he had some code and some hardware. And we said, okay, we can make this thing smart, so people can connect to it with the phone. It becomes a hub. Well, he had the prototype of hardware, and he had the code. So he contributed all that, including his time and skills, because he was interested in just testing his own devices on in a different application context. Okay, and if he wanted to get feedback from users on his stuff. So that was another type of incentive. It was not trying to sell something. It was just trying to get feedback and see if his system performs well in that kind of environment. And in the background, with glasses, you have an artist, and she was part of designing the whole thing. Yeah, her interest is that this public furniture could be a platform for her to distribute her artwork. And she contributed with skills and time for the aesthetic aspects of this thing. So what we understand here is that this context of production, there's a bunch of resources that flow in, okay, to be used under certain rules and agreements, and we're not operating as a company that buys or leases or rents equipment. We are providing incentives for people to contribute with their own resources to a particular production activity. So this is not market-based, right? And now when it comes to distribution, we can look at this slide here. Well, it's also, again, production, but you have the distribution side. So every time we do something, a project, we involve what we call stakeholders. So we work with NGOs, we work with universities, private companies, like we saw in the previous example. We saw 2 private companies involved in this project. But sometimes we work with universities, we work with professors, and most of the time we work with NGOs that have an interest in this open source technologies hardware that we develop for their communities that they serve. So everybody supplies something and everybody has a stake in it, right? So the private company, they can supply an engineer, they can supply money because maybe they want to fabricate this thing. That's their interest, okay? Or maybe they want to, I don't know, get exposed to a new technology. The university professors and students, sometimes they have some research going on, and they want to have their research be applied in a practical context. So they can turn around and ask for more funding because now their thing got applied and it serves some, I don't know, some local community somewhere. So there's a purpose, there's and there's an impact of their research, and sometimes they can make the whole project a sort of a case study, or somebody can have his master's thesis done on this project. So they supply ideas, they supply students, and they also make the project visible because then they publish scientific papers that acknowledge this project, and they propagate it and people know about it and so on, and provides more credibility, right? Because it was published in a scientific paper, whatever. The NGO, they can provide relations, they can provide ideas for designs, and they can tweak the horn for you for your project, so provide a sort of a marketing kind of function. And why they're there? Why are they spending the time with you? It's because they may be interested in what you're doing. So if you're making, let's say, a new open source pump for irrigation, they're probably in contact with some communities in, I don't know, in Brazil that would like to use this kind of devices, right? So they have a direct interest in connecting you with actual users of this thing. And when it comes to the distribution, we're not making products. So that distribution is not market-based. Essentially, what we publish is, what we disseminate is the model, okay? And the model is designed with do-it-yourself in mind, or with cosmolocalism in mind. So the way we design that open source irrigation pump, for example, is that anybody with makerspace level technical capabilities can actually make one with very little help from us. Okay, so we're not distributing products; we're disseminating models or designs or blueprints that have been tested, probably with the help of the university, and probably also tested with the help of the engineer from the private company, whatever. Yeah, so these models become, you know, they're good models, they're tested models. They have been designed with input from local communities that maybe came through the NGO. So they're good designs, right? So people can have confidence in that. We disseminate that, and there's the case to like Billy, who's here, likes to put it. There is an energy potential here. There's an energy differential where you can extract some benefits from the network. So how do you make a living doing that if you're just offering stuff for free? So first of all, resources flow into these production units through these partners, including money. Okay, so the company can give money. You can get money from grants through the public institution. The NGO can give you money. So all this development effort. So this is part of Sensorica's reality, right? So now we're running a project. We just had a grant from in collaboration with the local university. So this is not hypothetical stuff. We've done many things like that. But you have to set up an ecosystem, okay, in order to allow this resource flow into the production unit. And so all these resources from the stakeholders pour in, and you offer them whatever they're interested in. So the private company, you offer them a deal to manufacture this. To the public institution, you offer them an opportunity for a student to do a master's thesis on the project, or a PhD thesis on the project, and to validate their research and to publish new papers, which is their currency. And the NGO, you know, you offer them the possibility to tie relations with their clients, okay, their local communities. So everybody has a stake in it, and everybody then contributes stuff. So resources flow this way into the production unit. And then, so how do you make a living? Well, through what we call ecosystem services. Ecosystem services, right? So once you have something out there, people need to kind of, you know, people need to find these things. So you can offer a platform with a library of tested and proven designs. You can have a forum where you can run a forum where people can you know, interact with other people and help each other to build the thing, and to, I don't know, propose the ideas about improvements. You can offer, these are ecosystem services, meaning you offer infrastructure and services to the entire ecosystem. Or you can offer, I don't know, you can offer services. So somebody wants that thing, but with some slight modifications. And you can offer a limited production, you know, service. Somebody would want, I don't know, 20 of those, and they don't want to make them themselves. They want to do it in their hands, whatever. They don't know, they don't have the skills, so they come to you and you make them. Or you send them some kits, and they assemble it as like you do with IKEA stuff. So the network. Now we're talking about the flows to consumption. The network does not make the subsistence of the network does not rely on selling products. So there is no market. So the market as a distribution channel, or the market as a pattern of flow of resources from production to consumption, it's not the main driver. Okay? What gets disseminated are designs, and then you have a bunch of other services, which we call ecosystem services, that people would pay for, or give you something in return. Okay, that could be sustained by an NGO. That could be sustained. The services could be sustained by the government, or it just could be sustained by everybody that produces that thing. And we have something interesting in the pipeline now, where there are some of these things that get designed that are very sensitive to quality, and for that reason, people would have to you know, buy the certainty that the blueprint is the canonical blueprint, the tested and proven blueprint. So this is the case of medical devices. Okay, so if your network produces a medical device, then the patient, in relation to the doctor, can only use this device if there is a certification that that blueprint from which the device was made is genuine, is authentic, is not just a fork with some slight modifications that haven't been tested before. So we call that a trust economy, and then there's great potential to extract some value for the network from that. Okay, so that's another ecosystem service is trust. Okay, you provide trust in some cases. So in terms of so how do you make this happen, right? Technologically speaking, everything starts with REA, which is like resource events agents. It's an ontology. It was proposed maybe 20 to 30 years ago by William McCarthy. So it's an accounting and economic ontology. From that, Bob and Lynn that you saw in the picture, that's why I said that they're an important node in the history of this. They created value flows, which is a vocabulary for distributed economic networks, for the next economy, by which they mean the peer-to-peer economy, to coordinate the creation, distribution, and exchange of economic resources. Okay, so a vocabulary for distributed economic networks. In other words, for open value networks. So we have different languages, but we speak about the same thing for the context of the peer-to-peer economy. Value flows was then, so before even value flows existed, Bob and Lynn worked with us to implement REA into what we call the Web2 NRP CAS, which stands for Network Resource Planning and Contribution Accounting. So these are digital tools that are similar to ERPs like SAP, right? Like enterprise resource planning. All the small, medium, large enterprises, they use ERPs to manage their processes and resources. The best known one is SAP, right? SAP. So this is a SAP made not for corporations but for open networks. Okay. So we took the REA and we did an implementation in Web2, which is the NRPCS, which is the software that Sensorica used. So now you can manage inventory of resources that flow into production units under various property regimes. Okay, so there's somebody that says, I have a 3D printer in my basement sitting idle. I'm going to bring it to the lab, and people can use it under these conditions. Okay, or hey, we bought a new CNC machine because we had a grant, but because it came from a grant, it doesn't really belong to anyone. It just belongs to everyone. But here's the rules of accessing this. You have to be trained by that person, so you don't kill yourself or you don't destroy the machine. You have to use it for projects that are open source, blah blah blah. Okay, and that's a non-dominion form of property. Okay. The lab itself is a non-dominion form of property, so you can use the lab. So resources are flowing, right? And you have the inventory, resource management, that kind of just aggregates a bunch of resources. Some stuff could be in somebody's basement. Some stuff could be at the lab, but you still have an inventory of things under different property regimes, and you know precisely what are the rules of access or use. And then you have all these processes in the context of a project, okay, that trace the use of all these resources, including people's time. Okay, so that's what the NRP does. And then you build a ledger of economic activity. So a ledger of economic activity is TB that day used that 3D printer to prototype this thing, and that 3D printer belonged to that guy. So now he has a contribution to indirectly. And then he used the CNC machine that belongs to the network. So maybe there's a small contribution also that goes indirectly to the whole network. And then he used some materials that he bought himself. Maybe it was I don't know, the plastic wire that went into the 3D printer. So this is the economic ledger that the NRP spits out that gives you a full representation of what happens in a production context and how these resources flow in from where, and also has the rules to kind of kick back or incentivize these people that are providing these resources. Okay. So once we did the NRP, then Bob and Lynn, they abstracted the NRP and they created this vocabulary just to make it more generic so other people can use it. And then Holochain came along, and somebody took the value flows vocabulary and did a Holochain implementation of the REA resource agent, how do you say, ontology. So now the HREA, which is the holochain REA, uses value flow, and it constitutes the backbone of what we call a next generation NRPCS. Okay, so we are at this junction in our history where we have to transition from this Web 2 NRP to the next generation NRP that sits on top of a proper peer-to-peer infrastructure and using this backend, the holochain REA, and this was done on top of holochain. Okay, now the same thing could be done on top of blockchain. Knowing that the blockchain has a lot of bottlenecks to scale these globally, right? Because you have a lot of transactions when it comes to production. Every little access and use of a resource, and time contributions and financial contributions and contributions with materials to a project, everything is a transaction that has to be kind of put in a ledger in order to have this ledger of economic activity. So you can trace back and know how to incentivize collaboration and investment with time and money and resources, in order to have all these stakeholders stick around and be interested to collaborate. Otherwise, if there's no deal, they would not do it, right? So you kind of have to bake this deal somewhere in a ledger, which attests their contribution, which is tied to rewards, right? So you kind of have to set that incentive space up in order to allow these networks to function, allow these resources to start flowing into production units. Otherwise, they will not show up. So there's a lot of transaction, and a blockchain implementation could be a little heavy. But anyway, we're open to work with people in the blockchain space to do some prototypes and test it out and see how it works. For now, there is a lot of development. So this thing here, Holo REA, this is what would have to be done in the case of blockchain, which is an implementation of value flows on top of holochain, on top of a blockchain, could be, I don't know, Ethereum or something, that would lead to a next generation NRP on blockchain. Okay, so we're open to kind of work with both ecosystems, the holochain ecosystem and the blockchain ecosystem, just to see where these things can lead. And Sensorica could be this place where we experiment with these prototypes. Anyway, that's about it. If you want to dive into the REA model, there's slides from William McCarthy. Like, how do you represent a resource in a network environment, and how do you represent the process in a network environment, and how do resources and processes interact? And when it comes to production scheduling and accountability, everything, the model takes care of all that. So essentially, the REA model, you can essentially use the REA ontology to produce any economic statement in a network environment. Okay, any economic event is representable within this with the help of this ontology. So me accessing a 3D printer that belongs to someone and is in his basement, that event can be represented here together with I don't know, the incentive system and the scheduling of the project and everything else. So that's what allows it to do. Okay, so we could go for some questions maybe. Are you still there?
Yes, we've been coming along with you. Thank you.
Okay.
Man, that was dense. That was densely packed.
Well, we can unpack some of that.
I have sort of a well, I have a question, but also first an observation. I've been thinking a lot about I've been thinking a lot about what I've been calling the intersubjective field, right? This idea of like sometimes that there are places where a vibe or an atmosphere is present, and that it actually has enormous like economic value, and it sort of leads to this observation that paradoxically, the digital economy is emphasizing the analog in a weird way, right? I live in this apartment, above this beautiful. I'm looking out at a beer garden right now, and it's clear that that the majority of what I'm paying rent for in this apartment is what was previously called an externality of how cool the neighborhood is. It's a continuous analog flow that's very different from sort of the digital value of what is the dollar utility cost of this asset. So there's this strange way that continuous value becomes more central than sort of enumerated value in sort of late capitalism. And it seems like that maps on to, it's nice that you mentioned Uber, this concept of like Uberification, right? As far as I know, the big thesis for that sort of startup model was, don't worry about income at all. Capture network effects, right? Get the stuff, get that ether out there, and then everything else will come after, and then you'll be rich. Don't worry about it. I mean, what they really did was they just did a completely unsustainable model. All the taxis, everyone's looking at them like, how the fuck are they making any money? And they weren't making any money, right? And then once they had captured all the network effects, then they charged paid the driver shit and charged way more for the price. But it was already the situation had already they'd already won. So I don't know. It's clear that there's a relation between that and this open value model that is somehow foregrounding cooperative, like sort of continuous cooperative or affective energy, and transplanting that to the realm of material production. Yeah, well, I'll stop there. I have another question about like sort of circulating this concept, because I think it's also kind of dense. Like the open value network model is something that that you kind of have to. I'm very familiar with it. I've been reading about it for years. I've been reading your and Michelle Valens stuff for years, but it still has that gap of like a real crisp, intuitive grasp of it, and I think that's perhaps why the Ethereum ecosystem, for example, hasn't really latched onto it yet, because it just, I guess, so my part two question, sorry to just pile up, is what does it look like to sort of add mimetic, like give that mimetic thrust or that reproducibility to this concept so that it can be more readily available and more intuitive for people?
Yeah, it's interesting. Actually, Billy, in some of our discussions, he was advising how to communicate these better, and he's talking to people about Sensorica and experimenting, getting feedback, and experimenting with different ways to kind of communicate it in simpler terms and in a way that people perceive something interesting into it. But let me just start with your first question, and maybe Billy has something to say after. But this intangible that would draw people into this, you have to experience it to know it. It's being able to engage into like physical production in a permissionless way. It's a transformative experience for people. Okay, so you probably had that moment first time you went to Wikipedia and realized that, oh shit, I can edit this page and I don't even need an account. I just have to press here and boom, hey, I'm editing Wikipedia. And the same thing with Bitcoin after. It's like, wow, I can just become a miner. What do you mean? I can just make a living without asking anybody anything, So that's a sort of interesting thing. It's like you break the shackles of a slave for the first time, It's like this is a permissionless economy, and when people understand that, they have a wow moment, and then the aha moment comes when they really grasp the whole concept, right? But you have to play the game in order to go through that experience. And that's suffocated by the fact that these are still marginal processes that don't allow you to fully sustain your life. So, Sensorica goes up and down. So bang, we have a project, we have some grants coming in, they're flowing from an institution into the network. Now we can distribute that. People come, you have a bunch of contributors and activities, and then the project ends, and most of the people then, because it's just the 1% that have the entrepreneurial skills to bring in the next project, reality knocks on the door and they have to put their head down and go back to their job, and they hate it. So it's kind of suffocated by the fact that we still live in capitalism. It's hard to make a living on the edge, and people have to, once they have the wow moment, they have to deal with reality. So that intangible that is out there is experiencing a life of a free economic agent that could draw people in. And again, you need to experience it to know what it is. And when it comes to encapsulate these things, to communicate them better, I don't know, maybe Billy has something to say about how do you communicate Sensorica to people that see it for the first time? Yeah, maybe you can add something to this and just make it more. Yeah.
Well, number of different things to say. To add a comment to Exiant's original comment description of his flat, where he's got a flat, but the reason he's paying extra for the flat is because of the amenities that are in the local area. You can see that the differentials in some of the property markets. For example, single-person flats are always higher priced in terms of rental and sales in areas where, one-bedroom flats are always priced higher in areas where there's a large amount of entertainment, large amount of local entertainment or local entertainment, whether it's bars, restaurants, the local entertainment districts. However, two-bedroom flats and two-bedroom houses, you always get much more fluctuations according to the quality of the schools in the local area, because two-bedroom flats are usually for at least one couple with one child, for example, and that's you'll see that standard for the property market all over England, for example. But if you don't have, if you haven't hit the stage where you're having children, and sprouting podlings, then you're not necessarily, you won't necessarily have had that experience yet. It's something that I realized after I hadn't realized that was what was taking place until I actually lived through it, and that was something. It was an interesting experience. But what was it? The other aspects of what they were talking about. There was a story I got from one friend who was he had a lighting rig, video projector that was using it for doing lighting during festivals and gigs, and he was originally bought the damn thing so he could display his art and use it for his own artworks. So as soon as he realized that he needed to pay for it. So what happened? But he was working and was renting this thing out. And after about when I saw him on one Saturday morning, he was wandering around the house, grumpy and hungover at the fact that when he got the video projector returned, one of the lenses was cracked. And he was complaining about that. And I said, well, look, dude, how often have you lent it out? And he's like, oh, no, he said, sit down. write a list of how long you've rented it, how often you've rented it out, how often, how much money you've made from each rental. And then when he looked, once he'd actually, and said, then tell me what the numbers are at the end. As soon as he did that, he realized, hang on a minute, it paid for itself last month. I'd made enough money just from the rentals that the damn thing had paid for itself. And that was the point where he said, great, you can now choose your customers. You've now got the option to when someone unreliable turns up saying, hey, I'd like to rent this, I'll pay you 50 quid. And it's like, you're saying, no, that's not enough. You're not paying a deposit. And last time you borrowed it, you screwed up, you damaged some of the lenses. No, I don't need it. Point is that now he was able to he's got that equipment, and he was able to then use that equipment for the original purposes he intended it for. Now, whenever I'm doing stuff down at the Fab Lab or the London Hackspace, for example, we've got a whole range of different hardware that we all clubbed together and bought and built ourselves. And the main thing that we're looking at is when I was looking at the workshop and thinking, hey, this is great. Everyone should have access to one of these things. But the way that I ended up looking at it, thinking, well, hang on, why the hell would someone want a workshop? I'm an engineer. Workshop is living and building workshops is my meat and drink. But the actual most people don't want to buy a drill. They just want a hole. They don't want the utility of the machine. They want the results that it's got, that you can get from it using it. So I was trying to work out different ways of creating product lines that you could use specifically to create, for example, the furniture that you were showing was a nice example. That Matryoshka was an interesting example of something that you can, a standard design that you can make with a CNC machine. Mm-hmm. In the chat, I put a link to the Open Desk line of products, where they've got a whole range of fancy designer desk office furniture, and which is really, really nice and really, really good quality. And it can all be made with a single CNC machine that can get a CNC machine that's sufficient to carve out 4x8 sheets of plywood accurately, and you can make this sort of furniture easily. They've specifically aimed at the high value designer office furniture market niche as a way of paying for their CNC machines. Once you've got the CNC machine operating and it's paid for, you can use what they like for it. And so I'm just thinking, the way that I'm looking at it is that none of the network of CNC machines that they've got, those are in the long run, they should be competing with IKEA. They should be competing with Walmart. Because if you've got a local fabricator, hey, that gives you better quality results just by manufacturing from better quality materials, but gets you the products for the same price, then no brainer, man. Sorry, I think Seth was looking to say something.
Mm-hmm.
Yeah. First of all, loving all this. I've been following value flows from afar, and really resonating with all of these ideas. I am kind of like wondering about like your thoughts on why some of this stuff has like sort of stalled out, maybe for like a couple of decades, like some similar ideas. And yeah, just to maybe play devil's advocate a little bit, I'm wondering, like 3D printing, right? Was like the source of a lot of like these revolutionary ideas like 10, 20 years ago. And that it doesn't seem to have really taken off in the way a lot of like people basing their like utopian visions on. So like, like is that like a major cause, or, and do you still believe in 3D printing as the most promising direction? Like, is it like AI? It's just needs another couple decades and it's going to blow up, or are there some more like larger fundamental problems? For instance, like I'll just say this really quick. Like I was involved in a project, BridgeSpace, which some other people on this call were, and there was like a lot of like talk and effort around like bringing a CNC machine in, maybe doing a makerspace, I think they actually got one in. Like James, maybe you can like you can verify some of this, but like yeah, like and in the end, like it just sat there, I believe, and like no one did anything with it. And I imagine that that's not. What's that?
It was a 3D printer.
3D printer, sorry. But yeah, I'm wondering, is that like a representative example? Are there just some big unsolved problems out there that are keeping people from doing this? I'll just maybe like
yeah. So you see on top here, on top of the thing, the white shelves there. There's a device. That's entirely 3D printed, and it's a decanter centrifuge. Okay, it's a sort of a device to separate solids from fluids. You know, there's the hype, right? There's the hype, and in reality never reaches the hype. But yeah, 3D printers are useful. We use it. We're just going to make about 40 devices for local hospital, and we're going to use a 3D printer for that. You know, other machines are useful, but you know they have their own you know, advantages and disadvantages. Maybe for some things the CNC is better than a 3D printer. But there's definitely some things that you can only do with a 3D printer. And since now you have like metal 3D printers and all that, you know, I see people building, designing very complex structures, engines with exhausts and, you know, stuff like that. So, you know, you can only do it with a 3D printer. Anyway, but yeah, just to add a little bit to that question of how do you communicate at like material pair production? You know, like why doesn't it take off? So first of all, there's a problem with technology. So now Materium solves it's a missing link to connect peer production activities, like material peer production activities, with the blockchain space. So technologically speaking, we were not there. Doing material pair production is much more complex than just having a very simple service, digital service online. Like producing the Bitcoin service, it's very simple. Making stuff, like physical stuff, it's more complicated. And then you have to tie the physical with the virtual. But here's how we see it. So first of all, there's a bridge to the traditional economy, and if you want to sort of a reason for why this is really interesting is what we call crowdsourcing R&D on demand. So we've done that in the past with many companies, meaning that there's a company that comes and they want to, you know, do their first steps with a new technology. It could be IoT. So we worked with a very old manufacturing plant that they just wanted to learn how they could make their stuff smart and go into maybe, I don't know, become a data business instead of just selling dead materials. So they wanted to understand IoT. So instead of hiring engineers and doing that in-house, which would be very expensive, or they even called some companies that they try to outsource that. Again, the price is very expensive. We help them save more than 50% of the costs of R&D costs by having Sensorica interfacing between them and the crowd. Okay, so we said, fine, we can help you do that, but everything is going to be open source. They said, no problem, because we're not looking at selling the products, we're looking at the data. So it doesn't matter who makes it, as long as it's dirt cheap for these IoT devices to be plugged into our thing. We have a business intelligence business model. We're not interested in the product that we'll develop. So perfect. There was a perfect match. They were not looking after the intellectual property of these IoT systems. Actually, they wanted people to compete on them for the fabrication in order to reduce cost so that their clients would adopt them and they could get the data and offer business intelligence services. Okay, so this is about making seals for pipes that are used in mining industry, in refineries, in piping, like how do you say, pipelines. So if you have a refinery and your seal breaks, you have to stop that pipeline. That's millions of dollars a day. So you need some IoT device to do predictive maintenance. You know, so that was their business, and we worked with them. So one of the things that people can talk about is, well, we can interface with capitalism. Peer production can interface with capitalism through this service. Crowdsource R&D on demand. You need something, you need innovation. Well, you can outsource this, do it in-house, or crowdsource it. So now, how do you crowdsource it? Well, you give us your specifications, okay? We turn that into an open source project. We distribute that to the network, and we steward all these activities of I don't know, design and prototyping, and then we ship that back to you. And you're on top of this thing in real time. You see what everybody's doing because everything gets documented. Okay, so the way it happened to us is that every two weeks they would sign a check and send it to a custodian of Sensorica, nonprofit organization, and that check would get distributed to everybody that would work on this project, no matter where they were and who they were. And if the guy is in Africa and they cannot receive, I don't know, PayPal, you can turn it into cryptocurrency and pay that guy. Now you have a brain sitting in the middle of Africa that doesn't have a job. Now you're tapping into these brains that instead of bringing them here as immigrants, they can stay there within their social support structure and contribute to these projects. And it turns out this kind of innovation, crowdsourced R&D on demand, make you save at least 50% of the costs if you would otherwise outsource or do it in-house. Hire engineers, pay all these benefits, blah, 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 pay full-time salary when the engineer sometimes has nothing to do. You know, so there is all these extra costs that the normal way of doing things, you know. So and then even the resources for prototyping, the company doesn't have to pay everything because you may have some other stakeholders somewhere that are also interested in this project for other reasons that are not competitive with your initial sponsor, and they also pour resources in. So now they're mutualizing resources flowing into this R&D cluster, right? So instead of just working with one sponsor that wants to crowdsource some R&D, now you're attaching another 2 or 3. So then they're mutualizing all the process. So now your cost reductions for R&D, they're huge. But how do you do that? Well, you need that infrastructure. You need the open value network model, which is the crowd side. And then you need these interfaces with your sponsors, with your firms. Okay, so that is a sort of a bridge, that is a sort of a service between the peer-to-peer economy and the classical economy. And then you can have the pure peer-to-peer stuff that I showed you, where we worked with all these stakeholders to produce designs destined for do-it-yourself or for the but that's way far out. People are not interested in that because there is no money in that. Okay, so if you want a little story for a hype is, well, fine, this system helps you reduce at least 50% of your R&D costs. Okay, the thing is that you have to be open source. That's a requirement because open networks cannot keep secrets. And so now you're playing this innovation speed game instead of playing the protection game, which is not a problem because in high tech everything evolves with a cycle of 6 months. So who cares about that patent, right? So it just makes sense. And so you save money for innovation, and that's the I guess that's one sales pitch, right? Crowdsourced R&D on demand. You had another question?
I had something to throw in. Also, I want to give space for I was going to say for Van or Christina if they had any questions before we wrap up, because kind of I can go on, you can go on, but just want to make sure. Yeah, I mean, I think just want to suggest that the scarcity, the model of scarcity and abundance is really like thinking about yeah, the ability of, for one, the transition to sort of protocolization, I think is key here, and the power of protocolization in the sense of yeah, we can fork what's happening when you have this decentralized production, just in the case of CNC machines, is that you have local implementations of a protocol for making a piece of furniture or something, right? Well, then that person finds that because of their climate or cultural situation or artistic sensibility or whatever contingency, that it's that they would like to tweak the product, essentially fork the protocol, and the process of forking the protocol means that that it's very low cost for them to it costs virtually nothing for them to return and show their tweak and contribute it back to the global knowledge set. And so now you have this this GitHub repository of forking material protocols that work for all these contingencies. And one person may have done their fork because it worked for a certain climate, in North Africa. Well, another person finds in Ireland a completely different use for that same contingency, but then tweaks it a little bit like this. And that 5,000 Einstein, that 5,000 Einsteins, but spreading out according to local contingencies, it begins to well, I sort of lost track, but just to say that there's another element of abundance and scarcity.
So yeah, so what you're talking about is a part of remix of digital of knowledge, ideas, models. So that could be encapsulated as digital assets, and so they can flow in that way, like remix and fork, and access is allowed. Because they're seen as commons, so that boosts up innovation, right? Speeds up innovation. That's good. So whoever plays the innovation game, the speed game, they better play that one, and they'll win in the marketplace. But transpose that to physical resources, which is the topic of this discussion. The same thing happens with pools of resources or pools of what we call pools of shareable resources or non-dominium physical resources. Okay, these new forms of property attached to physical assets. So you're also making them fluid, easily accessible, and so they become shareable. People mutualize them, right? So now you have you understand that you reduce the costs of these materials, these access to these facilities a lot. That's why it makes sense to go to a makerspace and prototype your thing instead of doing it on your own or outsource your activity, because the makerspace mutualizes these tools, so their costs are low because a lot of people get to use them. So the same thing applies. So you have hyper innovation with commons, open source designs, and you can have hyper production because, in a sense, a local production, because now you have better ways to utilize these material assets in a way that they don't just sit idle, right? So you reduce the redundancy of all these production assets in the economy. And what happens when a company goes bankrupt? Well, a lot of things are just sold for scrap,
Seth, jump in, won't you?
Yeah, I'm loving this conversation, by the way. Yeah, so I guess there's one couple questions keep coming back to me, and mainly around the legal system and trust, which you mentioned as a potential ecosystem service. And I think Bitcoin is a good example to look at here, because I mean, it was sort of intentionally designed, according to Satoshi Nakamoto, to replace the state monopoly on violence, in order to create trust, right? But also hella illegal, and the government's been trying to shut it down most of this time. And so when I hear something like Materium, which I'm a huge fan of, I think that's going to unlock so much. And like, but I'm still sort of suspicious that like our current system, legal system and whatnot, is efficient enough and has enough legitimacy with a lot with the population to enable a lot of this stuff. And so I'm sort of like wondering a couple questions, like A, do you think that there's sort of a legal arbitrage? I mean, kind of like the one you already mentioned with, you know, like if the guy in Africa or the girl in Africa, you know, can't get paid via his banking system, you know, you just pay them via crypto, right? Like already I'm seeing stuff like that. But like, is there going to be required some sort of like redesigning from first principles, which is kind of which kind of like leads into trust and reputation systems, which is something that I've been working on myself. You know, can trust and reputation systems, for instance, replace what private property is doing effectively enough? Like, can it actually do the job in the way that Bitcoin was able to do the job of money, however imperfectly at first?
We have a nice case. I can actually put the link in the menu here. Let me just find it. Trust economy here. So this is applied to a live project that we just got a grant a few months ago. A model for sustainable material peer production. How do you make peer production sustainable through what we call a trust economy? So here's a document. You can take a look at it later. So trust is very important, and in some cases is driving the sort of the revenue model, if you want, or the incentive model. So this is in the space of medical devices, right? And if you have something that is open source and do it yourself, you run it through Health Canada or FDA, they have no way to deal with it. Okay, so how do you approve that as a medical device? Because you know the trust mechanism in the current system is that it's attached to a company. It's attached to an organization that is now regulated, so it's obliged to follow certain rules. So they're gonna ask like, well, who designed this thing? Like, who are the engineers that designed this thing, and who manufactures it? And your answers are gonna be networks. So who designs an open network? Okay, and who produces it? Well, maybe the patient. Maybe it's gonna be made in a fab lab. It's like, you know, their heads are gonna blow up with that type of answer. So so how do you reestablish trust in this kind of event? Well, it's all described in the document, but essentially what it is it's just a sketch in the document. It's just a sketch, but we're starting to prototype it in the next weeks, actually, with a group from Europe. It's just a basic idea. We're not even, I don't even know if that's going to be the implementation, or if we're going to follow that document, but that document describes the direction that we're taking. Maybe it's going to take a totally different form. So that document is just an indication. It's not the thing. But it describes the kind of the concept of the trust economy. So you can reestablish that using some other trust agents. Okay, so let's say, how do you trust that the blueprint is accurate? Well, the way you can do it is that you can build the thing. It doesn't matter who designs the thing. You can design it, and then you can give it to university to test it. Test the functionality, see if it's done according to ISO standards, and then have a peer-to-peer scientific publication paper about that. Okay, this thing functions this way within these parameters. That's according to the ISO standards. Here's a peer-to-peer publication published. That's a source of trust that you tie into the design, meaning that you hash the design and put the hash in the publication. So now whoever finds the design online from whatever, they can always just rehash it and see if it corresponds to that source of trust, which is the publication. And then because you're in the medical field, there's a doctor that uses this, does research with patients. So she uses exactly the same device, and she publishes another paper saying, well, I'm using it with patients. And then you take the hash of the design, embed it in that paper too. So now you have two papers, two sources of trust, one for the technical capabilities and the other one for the use, okay, that are peer reviewed, that are published there. These are your anchors of trust. And you know for sure that they link to that particular blueprint. Okay, so now you have 100% certainty that you are looking at a blueprint that the doctor worked with and these engineers at this university worked with, right? The uncertainty comes at the fabrication level. So how do you know that the execution is good? Okay, and there's a solution for that too. Meaning, for every little thing, you have the core electronic functionality. Let's say you have a pressure sensor, so you have your little electronic components that take data from that pressure sensor, and I don't know, that data it's pulled by a microcontroller, and maybe it's massaged in a certain way and sent to a computer. So how do you know that the people use the specified pressure sensor, and how do you know that they use the proper resistors and capacitors around, because you have to dress it up somehow. Well, you can build a layer of electronic components that are doing self-testing. Okay, so you can enhance your electronic design with another layer of electronics that is built to, let's say, measure the impedance or the capacitance or the resistance of that pressure sensor, which are fingerprints of that particular pressure sensor. So if the fabricator, which could be a guy in a makerspace, decides to cut some costs and pocket some money and buy that sensor from China, a knockoff, and not from Bosch, which is like half a price, then you can detect that. You can just detect that by having this layer around. So your blueprint can now include that self-testing layer for very key components. So you have a sort of a way for the patient, for the user, to validate, okay, self-check. What's the most key component in this thing? It's a pressure sensor. Okay, perfect. Is this pressure sensor the one that has been specified in the blueprint? And then you can just run the test, or just provide some pins outside and say, here, just use a multimeter that you can find anywhere. You can buy one online for $10. And if you get this number by measuring these things, you're fine. Or you can play the old game and say, here's a list of fab labs and makerspaces that do have the capabilities and the methodologies and the governance in place to make you that particular device. And that's the case for Sensorica. Well, Sensorica is not just a makerspace. We have, almost like 12, 14 years of existence. We have put governance in place. We have methodologies in place. So that could become a template. You want to become a fabricator of these things? Well, show us that you're properly structured. Show us that you have a proper methodology. Show us that you have a proper governance. And then you can be accredited by this network, which is another ecosystem service, accreditation, right? So the Fab Lab now is going to pay these innovators in this project, okay, for the accreditation, for being able to manufacture that thing. So there's different ways you can regain trust without having to anchor it into an institution. Like, we trust the banks. Why? Because they're regulated. So you need now to trust the government that regulates, the regulator, and the banks. But what happens is, like we see it with the pharmaceutical industry, the same people working in the pharmaceutical companies work at FDA. So you can't really, you can't trust the regulator and nor the fabricator. So the traditional model has a lot of holes into it, and so we don't have to make something perfect. Kind of have to make something that sort of works, as at least as good as the traditional case. And so you can actually use NFTs, blockchains, to create these snapshot in time of some blueprints that you call them the canonical design, and then hash it and embed that hash into scientific publications, which become your anchor of trust. So there's a distributed way to regain trust without necessarily anchoring it in key centralized institutions, right? And that could be applied in, just work with that model and see how you could adapt it to various material pure production settings, but there is a pattern there that we need to dig and develop.
if you look in traditional manufacturing engineering, the quality control that's used during the manufacturing process is that's a constant flow all the way through the factory. Every different stage of the process, you will have some form of quality control checks to check whether the components are being created properly, for example. That's an example of there's an existing process flow which you've now decentralized, because each of those parts of that process flow will be in different places, or possibly the full process flow in a single local space, which is geographically distant from wherever you happen to be. That's the thing is, as long as you've got that process flow built in to the whole rest of the rest of the process flow, so you can then add in, this is the test this is the way that you manufactured it. These are the results of the tests for this batch of components. At which point you'll be able to say this is a safe bet, because it was done in the manner that we actually that the existing manufacturers are currently using.
Yeah, and design ties into that, right? Because you can design specifically for distributed manufacturing, and this is what outsourcing, technology and precision of the mechanical, of lathes, and the mechanical precision of making parts, as it has improved, has allowed decentralization of production, outsourcing of stuff. So you don't have to, file and test the way they used to make horse carriages 200 years ago. You can buy the wheel of shell because you know that it's going to come within a tau of tolerance, and it's going to fit into your chassis, whatever. You know what I'm saying? So yes. So how do you design the components, or how do you architecture the device so that it can actually be decentralized? If it's something very complex, most of the things that we deal with now, they can be just manufactured on a table in a makerspace. So everything is in the same room, and we provide an instructable document, which is like step by step how to do things with the amount of time you should take. How do you plug in together? It's the IKEA kind of instructable, right? But because it's a medical device, we also take extra care to do the tests. So do this procedure first and do some tests. See if you have see if you have the proper voltage, and then put solder these other components, and watch out, because when you solder this, you may burn the other one if you're too close, and it's temperature resistant, sensitive. So yeah, so we take that into consideration, actually. So how do you design the thing for that particular assembly model? I think Seth has another question.
Yeah, I realize I was like, we've gone like a bit over, but I'm digging this conversation. And yeah, I kind of feel like playing devil's advocate a little more, just because I
good.
Productive.
That's healthy. Perfect.
Yeah, I mean, like, first of all, yeah, like I'm totally gonna read this paper on like the trust-based economic model. I think that there's a lot of value there, and like, as far as manufacturing as a use case goes, like maybe 3D printing is like AI, and it's just about to get a lot better and cheaper, and the quality control will be there. But like, I centralized companies like have an advantage here, and will continue to, in terms of like cost and quality control. And so it's likely that you're not going to be able to compete there. And then like talking about some of these sort of like legal arbitrage opportunities, like medical devices, which I totally agree with. Like, I've worked at a healthcare like tech startup, and it was like very disillusioning to see the like regulation of those devices. And I think it's basically criminal how much they cost. And you know, that's also the kind of thing that the government will crack down on really hard.
Well, with this project, we are engaging the government, and this is part of the grant, is to engage the government and say, how can we deal with this kind of new type of production? It's there, and it's not going to go away. It's just going to become more and more and more important. So we have a whole global strategy about how to bring this about. We're leveraging developing countries who don't have too many regulations, but they are in need of medical devices that are low cost. And then, so we're leveraging Canada to provide the trust in the quality of the research, the doctors that are working with this device at the hospital, to then go to the developing countries and say, you see, this is made in Canada. So can you, you want to use it? You want to go it through your regulatory system? And if that spreads out then from that point of acceptance into the developing world, then you have a critical mass, so you can come back to Canada and say, you see, now they're doing it, you know. So we're kind of having this strategy to play each other, to play the different strengths and weaknesses around the globe. But yeah, we're going to sit with the government and open this Pandora box and say, how sooner or later you have to start dealing with these things. But it's not. I'm 100% certain that this is going to be a very long and tedious, discussion. It's not the first time I'm speaking to lawyers and regulators, about open source and do-it-yourself and peer production. So when you talk about companies, yes. So coal mines are still run as during beginning of capitalism feudal system. They have their feudal structures. So capitalism has not completely evacuated guilds. They're still there, guilds. So there's a lot of social structure and organizational types that are still with us. That took shape during feudalism. So I don't expect everything to go away and the peer-to-peer economy being this utopian pure thing. So I totally agree with you that one thing that companies do well is quality control and manufacturing. They really do that well. And I don't know if it's good to outsource one-to-many production to networks. It doesn't make sense. Do it yourself, it makes sense, right? But it's not good for everything. So some things will be produced in massive numbers, and that will be done by companies. What I predict is that the same way companies were hollowed out of their IT department because it went to the cloud, the same way the same companies will be hollowed out of their financial department because it will go out to blockchains, and innovation will go to the network also. So what we see here is a sort of an erosion of the traditional firm, and you have functions that were internal before, and they just got extracted out by different ways of doing it. So if you're a company now, companies don't hire IT personnel anymore like they used to, because they just work things in the cloud, and just mysteriously things just get updated and always work. So you don't need to have your own service and run your application locally, right? That makes sense, and that's going to happen with the legal aspect of a company as more and more things will go to smart contracts, and that will happen to the financial kind of aspect of the company, because things will just be like smart contracts, blockchain, cryptocurrency, stuff like that. And innovation is the one that is slowly getting out, and we prove that with what we call R&D, manufacturing on demand. Like, who can resist over 50% reduction in innovation costs? Okay, they haven't figured that out yet. They still don't understand it yet, but it's there, it's real. It's just knocking on their door and they don't know about it. But it doesn't take long for innovation to be totally in the network. And what's going to be remaining of the firm is the manufacturing. I think that's a hard core to break the network is going to have difficult time breaking that, because companies, they get very good at specializing in manufacturing very precise something, okay, and with very high quality control, and that'll be the last role that they will have in the future economy, maybe for a long time. Even as, you know, fabrication, manufacturing gets more and more done by robots, you know, people will centralize robots and will probably put them under private property regimes, which is a firm. But the whole innovation stuff will just go out to the network, to the network. That's my prediction in the maybe longer term future, you know. So we're not competing with that kind of capabilities of high quality manufacturing, specialized manufacturing. We're not. I don't see that we have a chance there. But we can definitely compete with medical device companies that have huge profit margins, and sometimes they cannot even address small markets. Like with this project that we're doing with university is for cystic fibrosis. That's a rare disease. There's no market for the company. Capitalism cannot operate in that market. They cannot invest money to develop these things in a normal way, because there's no money to be made by them. Otherwise, the device would cost like thousands of dollars. And people can make it for $80. It doesn't make sense. You see, so we're inserting ourselves into places where corporations, they cannot operate because there is no market. There is not enough profit to be made, and also in spaces where there is probably a market, but we can beat them at the price, because people in developing countries, they'll just make their own stuff. Okay, so I think there is a case. So that's the sort of the crack in the system, is where there is no market. That's our crack. This is where we put our lever and make space for us, you know, and especially in the developing world, right? Because even if there is a market in Canada and the US, these people don't have money to pay for these devices, right? Forget it. So there is an empty space for us that we can just invade, and from there, who knows what's going to happen? Like, this is how you perfect material pure production. It's by addressing these spaces that cannot be reached by capital. Even if they want to destroy you, there's nothing in it for them. I mean, you're not a threat. You're just operating in a market that's not interesting for them. But this is where you grow your potential and capabilities, right? So it's a sort of that's sort of a strategy. How do you take over?